This lesson is about solving quadratic trigonometric equations, which means you need to be able to do two things. Solve a quadratic equation and also solve a trigonometric equation. Okay, there's going to be two parts to all of these problems. In the first example, we're trying to solve sine squared x equals a quarter over this domain. Why is this a quadratic equation? Because I've got a squared there. If I was trying to solve something like x squared equals 9, how would I go about solving it? Well, I'd need to take the plus or minus square root of both sides. Square rooting the left-hand side gets rid of the squared, and we get the plus or minus on the other side. So I'm going to do exactly the same thing to my sine squared x. To get sine x by itself, I'll have plus or minus square root of a quarter. What multiplied by itself gives a quarter? A half. So I'll solve the quadratic part of it. Now I've really set myself up two trigonometric equations to solve. Either sine x equals a half or sine x equals minus a half. So I'm going to solve these two equations independently and find all the values of x over this domain. I'll start by finding what my acute angle is, which will be the angle which gives me a sine of a half. I can use my exact value triangles or my memory, either one of those that you have. Okay, we should realize that to get sine of a half, my acute angle will be pi on 6. Okay, now I'm looking for where sine is positive. So sine is positive in 1 and 2. So I'll draw, here's pi on 6 and pi on 6. My two angles are going to be pi on 6 and pi minus pi on 6, which is 5 pi on 6. I can add and subtract the period of 2 pi, but I'm not going to get any more solutions because it's bounded by 0 and 2 pi. You can try that for yourself. On the other branch, sine x equals minus a half, I'm going to do the same thing. I'm going to find the acute angle, which is the angle which gives me a sine of a half. Notice that I ignore the negative. Again, using the same diagram, I'll get pi on 6, but in this case, I'm looking for where sine is negative. And we know that's in quadrants 3 and 4. Draw up my unit circle diagram in quadrants 3 and 4 of the x-axis. Mark an angle of pi on 6. So my two angles are pi plus pi on 6 and 2 pi minus pi on 6, which is 7 pi on 6 and 11 pi on 6. So overall, here are all my solutions. They are in ascending order: pi on 6, 5 pi on 6, 7 pi on 6, and 11 pi on 6. Okay, two skills at the top, quadratic; at the bottom, trigonometric. Let's look at another example that might be a little bit more complex. In this case, we've got a sine squared and a sine. Because some of these look a little bit scary for some students when there's sine squareds and sines all over the place, why don't we let m equal sine theta, so that I can rewrite this equation as 2m squared equals m. Okay, I haven't done anything, just change the signs to m's. This equation is a quadratic equation. Whenever we're solving a quadratic equation which we can't just take the square root of, we need to remember to do two things. Correction, three things. We'll set it equal to 0, we'll factorize, and then we'll use the Null Factor Law. It should be routine. So at the moment it's not equal to 0, so I'm going to set this equal to 0 by subtracting m from both sides. Done that. Now I need to factorize it. Since I only have two terms, I'm just looking for the common factor. I have a common factor of m, and when I factor that out, I'm left with 2m minus 1. Factorized, have it written as product of two things. Now I use the null factor law. I've got two things multiplying to equal 0. The only way that can be true is if this is 0 or this is 0. So I have two values. I have m equals 0 and I have 2m minus 1 equals 0, which means that m equals a half. So where I get to now is that I can resubstitute. I mean, it's great that we've found m, but we were solving this equation for theta. So I'm going to substitute m equals sine theta back into both of these branches, and I'll have from this equation m equals 0, so sine theta equals 0, and from this equation m equals a half, so sine theta equals a half. And you can go ahead and solve these two equations using trigonometric equation methods and find these angles theta. You're going to do this super quick. If you're struggling with this, go back and watch one of the previous videos. Okay, I know that sine is the y coordinate. This is the special case where sine is 0 or 1. I'll draw up my unit circle. I'll mark the 4 points. So I'm looking for where the y coordinate is 0. I can see there's a y coordinate of 0 and a y coordinate of 0. This is where the angle is either 0 or pi or 2 pi. So the solutions I get here are 0, pi, and 2 pi. Over on the other side, it's not equal to 0 or 1, so I find my acute angle, which will be inverse sine over half. My acute angle is pi on 6. I'm looking for where sine is positive, which is quadrants 1 and 2. Draw my diagram, mark pi on 6 on both of these areas. My two equations are pi on 6 and 5 pi on 6. So to write all my solutions in ascending order, I have 0, pi on 6, 5 pi on 6, pi, and 2 pi. Okay, lots of solutions there. There is one slightly harder example over the page. By a little bit different, I of course meant the most difficult problem that you'll do this year. Okay, so we've got this equation, same domain, 0 to 2 pi. We've got sine and cosine here. I'm not going to be able to do a substitution like I did in that previous example, because if I said let m equal sine and n equal cos, I'll get something like 2m squared equals n plus 1, and I can't solve for two unknowns. I can only solve for one unknown. So I'm going to have to recall my Pythagorean identity, and I'm going to substitute in that sine squared x equals 1 minus cos squared x. So where I see this sine squared x, I'm going to replace it with 1 minus cos squared x. So 2 lots of 1 minus cos squared x equals cos x plus 1. I'll do some expanding on the left hand side. Okay, and now I've got just cosines, so I'll let m be cosine x and see what happens. So we've got 2 minus 2 cos squared x, so m squared equals m plus 1. Again, I've got a quadratic equation. Remember, set it equal to 0, factorize, and null factor law. So I'll set it equal to 0, bring everything to the left-hand side. So 2 minus 2m squared minus m minus 1. And then I'm collecting like terms, so the 2m squared will stay the same, the m will stay there. I've got 2 minus 1, which is positive 1. I'm going to factorize this. I don't like factorizing with a negative a value, so I'm going to multiply everything by minus 1, which will change all of these signs, negative to positive, and positive to negative. Now I can go ahead and factorize this. It'll factor to 2m minus 1, m plus 1. Okay, if you need to factor, revise factorization, go ahead and do that. So I've set it equal to 0, I've factorized it, now I'll use my null factor law. So 2m minus 1 is 0, or m plus 1 is 0. So I'll get 2m is 1, m is a half, or m is minus 1 as my two solutions. Remember, I wasn't trying to solve for m, I was trying to solve for x, so I'm going to substitute back in m equals cosine x. So I'm really trying to solve these two equations. Okay, which you can definitely go ahead and do yourself. Press pause, do it. I'll put a solution down here as well. I'll end up with these three solutions. If you're unsure whether they're correct, you can go all the way back up the top and substitute them in, make sure that's true. Alright, to practice that, there's a few questions in the text for you to have a go at. Good luck.